Hello everybody and welcome to today's live stream. Today we're going to be covering some of the 3D toolpath strategies in Fusion 360. On the keyboard as usual, and my wingman is my good buddy Mr. Brad Tallis. He's going to be answering any questions, and if you have questions for me, he'll get those over to me and I'll take a look and see if I can't address those and answer those for you. I do find that when we do these live streams, the 1 hour does go rather quickly, and there are times that we run out of time or we go over. Today's not that day. I can't go over today, but leave any comments and we'll be sure to get back to you. And if there's things we don't cover, we'll just do them on the next live stream. So let me take a quick look at the chat, make sure that there's no 911s or you guys cannot hear me or anything like that. Sometimes with these, no matter how much we prepare or actually don't change anything in our settings, there are times when my audio doesn't work or video doesn't work. So if you guys can put in the chat, if you could hear me fine, that will be appreciated. One other thing is a good colleague, a friend, Autodesker, had surgery the other day. I don't know if she's watching, but I wanted to wish her well in a speedy recovery. All right, thank you, Eyal and Klaus and Alex. Thank you. Okay, so let me switch to my screen. So we've been doing a series. Thank you, Moto Motion in Canada and Cool Modad. We've been doing a series. So first we started with the setup menu and we talked about everything in here and how to use them. We didn't talk about create manufacturing model. I'm gonna do that in another live stream. We then covered the 2D strategies where we covered all of these and how to utilize them. And now today what we're gonna do is cover the 3D strategies, and there's quite a bit, and I have some examples, and I'll do my best to cover them. And as I said, if we don't get to all of those, we'll just follow up with it next time on the next live stream in 2 weeks. Okay, so I'm gonna point to something in Fusion. If you see this part on my screen here, if you go to your data panel, and if you scroll down, you guys have access to this part. And I wanted to use this part so that you guys can look at it. So under samples, there's cam samples. Double click on that. A lot of goodness in here, a lot of samples, things about the manufacturing extension, Fusion Academy, Haas demos. So these are parts that we've done with Haas. And if you come down here to 3D milling overview of Toolpath, double click that, and that's going to be this part. And it has some sample toolpaths in there. And what I recommend is if you have a part and you're creating some toolpath, a lot of times what I'll do is I'll just recommend to people come in here, find something that works, that gives you something that you expect, and right mouse click and then copy it. And then you can go to navigate to your document. Let's say I've got another document here. And then you can paste it and utilize the same strategies, like all the settings. So that's a little pro tip that I like to use sometimes. So, okay, going back to this part. Let me close the data panel. Adaptive clearing, I've talked about a million times. I'm not going to spend a whole lot of time on this one because it is covered quite a bit. But what the difference is between adaptive and pocket clearing, this is exactly that. It's a roughing strategy. It's to remove as much material as possible in the quickest amount of time. Now the difference between adaptive and pocket. So adaptive is, let me switch over here. So the adaptive strategy, let me see if I have something. So the adaptive strategy is where the tool will go, you control the depth of the tool, and then you also control the radial engagement of the tool. And then so for the adaptive strategy, you want to utilize that full flute length of your end mill. And then the the side load, the radial load, you go a nice light load. Whereas on a standard pocketing strategy, it's kind of the opposite of that. The depth is shallow, but the sideways, the radial engagement is greater. So those are the two fundamental differences between the strategies. Adaptive is a constant engagement. So when you get into corners, you don't have to worry about the tool overloading. Okay, so let's come back to this screen. And I'm making sure I switch my screen. I don't know how many live streams I have forgotten to make this switch. And then everybody's commenting in there. All right, okay. Cool, okay, so let's come in and I'm just gonna look at my setup and see what is selected for my stock. So it looks like here on that, whoever created that, they're using the solid, but let's just do a relative size box. And here under stock offset mode, I'll just do no additional. So the yellow preview, if you could see that, is the stock. So there's no additional stock. All right. So now, once I created that, all these toolpaths got dirty. I need to regenerate. So I will right mouse click and hit generate. Fusion will go through and update everything. I got that beach ball. I'm on a Mac. On a Windows machine, you'll get the hourglass. Okay. So we're going to go through these and create all these toolpaths from scratch. But what I want to do, actually what I'll do, let me do this. Watch this. I'll just right mouse click and I'm going to duplicate. This is something that I do quite often. The shortcut is Control D or Command D on a Mac. So I'm going to duplicate that. And the reason why I'm doing this is because with the adaptive, if I add it to my this setup and it's down at the bottom, then with rest machining and things like that, and this, what I'm going to do on this new setup, I'm just going to go ahead and delete all of these toolpaths, and so we can start from scratch for today's demo. Okay, so I'll minimize that first one. So I'll just put in here LiveStream. All right, great. So in this setup, let me right mouse click and just verify everything looks good. Yep, looks good. All right, hit OK there. 3D adaptive clearing. Very first thing, I'm going to select a tool. Let that open up. And I'm going to come to this setup and let me see what tools I have. I can filter by milling, and anytime I'm on a using my bandwidth here, sometimes I have some slight lag, slight delay, so apologize for that. So I'm going to filter, and if my computer cooperates, I'll be able to filter. Give that a moment. Okay, there we go, flat and bull. So show me the flat and bull nose tools that are in that setup. So let's take this one here. Actually, I'll use this one. And I'll hit select. So we're using a 3/8 tool. That's approximately 10 millimeters for the international audience. Okay, so under geometry, I'm not going to select everything. I'm just going to leave everything as default. And let's see what, actually, I don't want to go below that. So under my heights, here under selection, instead of going to model bottom, I'll do a selection. And I'm going to zoom in here. Whoop, a little too far. And I'll select that floor there. So I don't want it to go below that, but actually I kind of do. I want it to hit this pocket. So what I can do is just give it an offset. Let's give it minus 250. I know there's many ways to handle all of this. That's just one way. So let's let this calculate, and we'll get our adaptive to clear all that material. And what Fusion will do is it will remove all that material, doing an adaptive strategy. Give that a moment. Commander Bimberly, sorry I'm late. All good, all good. These are recorded. You can go back and watch them. So what Fusion is doing is calculating, doing the constant engagement. So when it gets into the pockets and areas, it doesn't overcut or overload the tool. All right, my computer is not cooperating as far as being the greatest at speed today. Feel free to drop your comments in there. All right, so I see Ayal says, what is the deal with setting heights from contours? It never seems to work. I'll get to that. I will open up the heights tab. All right, so I got a bunch of linking and retracts. I can clean that up. I talked about this in previous. So under my linking, I can give it a bigger maximum stay down. So if you ever hover your mouse, it'll give you a tooltip. And so you see those yellow lines? So if that distance in that image there says 1 inch maximum stay down. So if that distance is greater than an inch, it will retract. So in the image to the right, it's been changed to 2 inches. So therefore, if the distance is less than 2 inches, the tool will stay down. So pro tip, depending on what machine you're using, but you can come in here and say whatever the distance of this part is, you know, the size of your part. So I can put in here something like, say, 20 inches. And then another thing, the feed rate when it's doing that move, how fast do you want it to go? So I'll put something like 800 inches a minute right there. And I will hit OK. Another thing, actually, before I hit OK, I like to turn smoothing on. And I recently was doing a demo and I cleared all my my defaults. But what I like to do is here, I'll right mouse click. Another pro tip, I'll edit the expression. And so I'll right mouse click, edit the expression, and I'll make it equal to my tolerance. And then that tolerance is controlled up here. So if I take this value and put in something like 0.01, then this value down here will update. When I hover over smoothing, what is smoothing? So by default, the adaptive strategy does a bunch of straight line moves. Kind of hard to tell, but in this image, there's a straight line where it says smoothing off, and there's little black dots. When you turn smoothing on, it will create an arc within that tolerance band. So you'll get a smoother toolpath and less lines of code, which will result in your machine motion being a lot smoother. Okay, so, and then people ask me, well, what number do I put here? I like to say whatever your stock to leave is, a good rule of thumb is maybe half that or a quarter of that. So yeah, I'll leave that at 10 just to speed things up. And let's highlight one more pro tip here. We've got this cavity here, this pocket. And here under ramp where we can helix in, couple of settings we have here. I like to make this 2 degrees or 3 degrees so that when the tool enters, it's not rubbing on the walls. It creates a little taper. You can really hear it at the machine tool. And then the ramp clearance height. This will be starting above by 100,000. I'm going to make that shorter so it doesn't start so high above. And then the helical ramp diameter, if I right mouse click, I can look at that expression. And it's taking a formula, basically 95% of my tool diameter. I'll cancel that. And the reason why I'm showing this one is this value is 327, so when it's entering, it's going to do a helical entry. And the helical entry, if this number is too big, the tool will never enter into that cavity. So what I like to do is I'll take the minimum, and I'll edit that, and I'll just do something like 0.25 times 0.25, so whatever the helical ramp diameter, divide that by 4 basically, and I'll hit OK. Now we get a smaller value here. So on helical entries, it will lean towards this number. If it needs to enter into a cavity or a slot, it will then use this value. There's also another setting under passes about machining cavities. So be mindful of that as well. So anyway, those are just some of my pro tips on the settings. And then If you turn this one on, calculation time will go a little bit longer, but let's skip that for now to save time. Let that calculate. I'll take a quick look at the chat and see what Mr. Brad passes on to me. All right, so yep, that same question from AL. Thanks, Brad. So remember how we had a bunch of yellow lines and retracts? Now if we're over here, we still have them, but there's not as many. So where it can stay down, the tool will stay down, and that yellow will go at that 800 inches a minute feed rate. So it results in a lot smoother toolpath. And let that calculate there. And some of those settings that I put on, so by default, let me switch, where's my mouse go? There we go. So by default, the settings are out of the box in Fusion set to calculate rather quickly. If you start modifying and hitting those checkboxes, turning smoothing on, tightening up the tolerance, calculation time will be increased, but it will result in a smoother toolpath. So be mindful of that, and if you need it, take the few minutes and create a smoother toolpath. You'll get a much better looking part, and the performance at the machine will be a lot smoother as well. All right, so now we've got our toolpath. We've got a bunch of retracts. I can change some settings, but let's move on to save time. And whenever you see this warning, if it's yellow, that's simply a notification. It's not a 911. It's not a red. If it's a red, you need to go back and address something. And what I'm looking at here is this bold text. It says rest machining adjustment reduced to maximum limit. So that tells me that Fusion did some automation there to achieve that toolpath. And look, the toolpath did go down into that cavity. So we can run a simulation now just to get an idea of this thing I need to dock over. There we go. And if we turn my stock on and let's run a simulate. We'll speed through that. I will turn transparent. Turn that off just so you get an idea. So we'll rough that part out. Klaus, will I talk about rest machining? Yes, I will talk about rest machining. So on that topic, so if I have a big diameter tool, let's say I have a 10 millimeter diameter tool, and I need to get in a fillet that's perhaps here smaller than 5 mils, let's say that's 2 mils, then I would have to come in there and remachine it with a smaller tool. So let's quickly do that. I will come into here, and what I'll do is just come to the pocket clearing, and let's pick a different tool, and let's see what I have here under my 3D milling toolpaths overview in that setup. So again, if I go, I can filter there, and let's look for a bull nose, and let's, instead of the 3/8 end mill, which is about 10 millimeters, let's go to the 1/4 inch end mill, which is about 6 millimeters. And what that will do, when you're in rest machining, you have the option here. You can say rest machining from the previous operation, or from file, from bodies, or from setup. So we already just machined it with tool number 5. We can see that there. But now if we come into here and just say machine from previous op, so it will take and only remove where there's material. I'm going to leave all these settings by default, with the exception of this one. And let me come into here, and my computer is been acting strange today. Sometimes I don't know if you guys can see that flicker, but it's not letting me. It could be a UI issue on my side. There it is. Okay, so I've got that bottom face selected. And here, let me give it a negative value so we enter down into that cavity. Now, I didn't create that model. I don't know exactly what that number is, but that looks pretty good right there. And let's hit OK. And what this will do with the rest machining will now enter into areas that this tool didn't reach. Someone says, oh no, inches. Commander Bimberly says that's Fusion issue. Yeah, I just started seeing that in the last few days, and I don't know why. But so what we see now is the tool is just remachining in some areas. You can see like in this corner, things of that nature. Now that might not be ideal, but to save some time, guys, I'm going to keep moving on because what we really want to get into is some of these toolpath strategies. I'm going to save steep and shallow for later because I want to expose some of these toolpaths like parallel. Okay, so parallel, what is that? Remember I was talking about a tooltip? If you just hover over, it'll show a tooltip with a slight, a little description about what it is. So I'm going to select parallel. I'm going to grab a tool. And this time, let me just come to this. And let's use this 1/4 inch ball end mill, 6.35 millimeters. And then under geometry, you can do a selection of a machining boundary. And I'm just going to say, keep it within this area. And then under tool containment, you've got some options. You can keep the tool inside that boundary. You can allow the tool to be centered on that boundary or allow the tool to go outside that boundary. Furthermore, you can give it an additional offset. Okay, so that's super powerful. Couple other things to pay attention to. Contact point boundary. If it's disabled, it will go like the center line of the tool centered on that boundary. If you enable it, the point of tangency on the right in that image, you'll see a different result. And then again, in those bottom images, you can see that as well. So be mindful of that. I'm going to turn that on. Contact only, what is that? If it's enabled, only where the tool is touching the model will it create a toolpath. If it's disabled, it will just cut air, like example over that hole. All right. All right. Klaus says, tried to stack 3 3D adaptives with rest machining, and somehow the third operation ignored the results of operations and calculated based on the first. Is this normal or did you do something wrong? Klaus, let me okay this. Are you positive that you have rest machining from previous op? Make sure you have, it says previous operation. Also, depending on the passes tab, if you have stock to leave, the value here, if Fusion doesn't see any material to remove, it'll ignore it. So be mindful of that. Okay. All right. Thanks, Brad, for dropping those questions in there and allowing us to talk about those. Okay, going back to this parallel toolpath, let's take a look what it did. Let me do a quick simulation. I'll turn off stock just so we're getting these red marks here because I didn't simulate it from the beginning. So those red tick marks are saying, hey, you're hitting some stock. Don't worry about that. Those are false collisions. So I probably wouldn't use this toolpath like this. But what it's doing is just running a parallel toolpath across that surface. And if I look at it here from the top down, so it's simply doing an even step over in the Y direction. You can change the direction of that toolpath. You can change the step over amount. There's some slope containments I'll talk about. Heights, I just left it all as default, but on passes, here we go. So the Stepover, remember we had a 1/4 inch tool, which is about 6 millimeters, and the Stepover is 0.125, which is about 3 millimeters. So you can change that value. You can type in a value here, or what I like to do is I right mouse click, edit the expression, another pro tip, and then you can give it a value here. So right now it's set up to be 50% of my tool diameter. I can do something like 0.01, or let's do, that's probably too much. Let's do this to save some time. So now our Stepover is 10%. Direction, you have some options here. You can go one way, other way, or both ways. You have some other control, axial offset passes. You can give it multiple Z depths. All kinds of goodness here. And then remember the toolpath was going left to right. You can change that. I can change that to 90 degrees. And that is from the x-axis of your setup. So in this setup, the x-axis is in this orientation, like this. So this is 90 degrees to that. So watch what happens when I hit OK. Now we have a toolpath that's a lot smoother. And if we come into this area, look where when it cascades over this edge, the Stepover is kind of greater, and then the toolpath will not be ideal there. So we have some things to control that. And remember I showed this top view. Holy moly, we're halfway through the hour. I just got a notification on my computer that we are halfway through the hour. Okay, so now when you look at it from this way, it is exactly Stepover of 0.025 inches. But when it gets to the slope, you get that. And you'll actually see that on your part. The surface finish may not be ideal. So we have some controls in there under parallel. Let's just create a, actually, I'm not even going to create a new one. I will just come here and duplicate this one. And this one, I'll right mouse click and edit. And again, taking a look at our settings. We've got here under the passes tab, machine steep areas. What is that? So what it'll do is it'll add some more passes, and then here you can give it some additional control. So again, this is a percentage of your tool diameter. So let's come into here and maybe make this guy a lot tighter. Something like this. Let's leave it at 10 thou. Again, I don't want to be too, I don't want to make it too small so that the calculation time is too much. But now let's see if we get something different. And again, you guys have access to that. So yeah, you can see here what Fusion did. If we toggle between these two, you get some differences. And that will certainly help, especially like on this side. This side looks a lot better. But maybe that's not the best toolpath for that. I also want to just point out quickly that you can change the angle of the passes. So let's say 45 and hit OK here. And now the toolpath will go to 45-degree angle. And while that is calculated, I'm going to show you guys how you can utilize some of the toolpaths, not just for like a mold or a die, but you can actually make some goodness like artwork type stuff. So a while back, I was tasked to do something, and I created a picture frame. We did it for a customer, and I used a parallel toolpath to make this Autodesk logo. And by changing that toolpath angle, I was able to achieve to give it some depth, so that the A looks so it has a little bit of depth to it. So, and I've got another example of the radial I'll show in a moment. So that was this part here. And if I come into here, here's that picture frame, and then we've got that Autodesk logo. And then by creating the parallel toolpath with the proper angle, I was able to achieve a nice, beautiful logo that actually gave it a little bit of depth. So with these toolpath strategies, you can manipulate them and get some good looking parts. All right, so let's come back to this one here. And then next, under parallel, we have scallop. So what is scallop? So what it'll do, it'll take that outer contour and just step over and collapse inward, like in that example there. So let's do that. We got a scallop. We're going to use the same tool under geometry. This time I'll pick this part. I'll leave all the settings as is. I will do contact point boundary. And what's my step over here? It's 50% of my tool diameter. Right mouse click, edit. And let's do something like 10% of my tool diameter. Right mouse click and say make default. Really quickly on this, what's the difference between reset to built-in default? That's out of the box, like the factory setting. Reset to default is your setting. So if I can toggle in between, the out-of-box experience or out-of-box default is 50%, or your personal one is this one. And if I hit OK, let's see what we get on this scallop toolpath. So we got some entry here, and it works outward. You can control all that, all those settings. So basically what I do, guys, is when I create a toolpath, I'll lean on the defaults, because what we do here at Fusion is to make sure that with the least amount of mouse clicks, you get a toolpath. You don't have to dot every I and cross every T. So what I do is I'll just grab a tool, maybe select the geometry and hit OK. A lot of times I won't even worry about my heights or passes, but what I did there. So here, direction, you can do both ways. You can do other way. So let me see, do we have a tool tip for that? Yeah, there we go. So you can modify the direction. And then up or down milling, you've got some options, up or down or both. So let's we'll just let's see what we get. A lot of tools we have at our disposal to give you some different toolpaths. So now we got some slightly different behavior. We did talk about, I briefly talked about here under geometry, we've got a thing called slope. What is that? Slope, you can contain the toolpath between certain angle. So that first image there, it's keeping the toolpath between 0 and 90. The middle image there is keeping the toolpath between 0 and 45 degrees. And then that third image there is keeping the toolpath between 45 and 90. So let's turn that on and let's keep it between 0 and let's pick 30 degrees. See what we get. So you got a lot of control. And it did that. Maybe if I didn't want to hit this, I can control that by, who can guess? I can go to the heights, right? I can just do a selection and just grab a point. I can even give that a minus 0.1. Just give it some value. Actually, I do 125, that tool. I could even type in minus. I can get nerdy and work on my expressions and stuff and really nerd out on that kind of stuff. On adaptive, remember we talked about the smoothing? We're going to talk about that here as well. Turn that guy on, and then what you'll get is a lot smoother toolpath. And then when you run the simulation here, we'll just run that really quick with no stock on. And instead of tail, I'll just do operation. And you can see that. And if we had, actually, I'm not even going to worry about that right now. But there's a parallel toolpath. Sorry, scallop. I was looking at the browser. All right. Okay. So next, what do we have here? We have contour. What is contour? Contour is for steep walls. And what we're going to do, we're going to use this. Now, I'll use the same tool. And let's pick this one again. And there we go. And I'm just gonna not worry about any other settings. I'll just select that outer edge and hit OK. And let's see what we get. So we can see that it hit this top area, the shallow area, and the step over, it's really big. But here on the steeper portions, it's a nice and smaller step down, so you get a smoother toolpath. So how we talked about parallel, where it will project that value, and that step over is equally spaced across, the contour is the opposite of that. So it's a lot better this way for vertical walls, but not that great on shallow strategies, which is why we have that steep and shallow. So what steep and shallow toolpath, this guy here, that'll combine parallel or scallop and a contour in one toolpath. And again, we'll get to that. I'm afraid we're going to run out of time. Holy moly, I need to speed up here. All right. Okay, so under the contour, if we let's take a look at some settings here. Geometry, again, we got slope, we've got rest machining, we got tool orientation. You could do avoid or touch. We can do that. I can just say, let's avoid. Come on. There. Oh. I don't know why it's doing that. It's flickering. And that just started. And of course, when I'm doing a live stream. All right. There we go. All right. Okay. So avoid or touch. I'm going to avoid that. And then you can give it a value. I'll leave it like that. Let that go. So now we get a little different toolpath. And now it's going to avoid that surface. Super powerful. And to take it one step further, let's duplicate this guy. And now we've got this one. And I'm going to, instead of how we did this, we'll leave this at silhouette. But what you can do, you can say, I want to touch certain faces. So you can say, I want to just touch. And there you go. Perfect. Good job, Angelo. My mouse is not cooperating. I wanted to touch that. And then instead of it avoiding it, it would touch. And I don't know why it's doing that on me. Oh, well, I'm going to skip this. Actually, what I did last time is move my mouse off the screen and then came back to it. Hey, there's my workaround. Move your mouse off the screen and bring it back. That worked. So now I can touch that, and I'll do a 0 offset. And then now, not that that was right. I probably should have picked this wall because that's more of a vertical steep wall. But I wanted to show you how you can leverage some of the tools in Fusion for your selection. Well, that's calculating. We'll let that go. I'm going to move on to the next toolpath. We have ramp. So ramp is similar to the contour, but it'll just do exactly that. It'll just ramp down. So here I'll do a selection and I'll grab this. What was that pro tip I just said? Move the mouse off the screen and come back. And there we go. Come on. Brad, help me out, man. There we go. There we go. All right, cool. And the settings, I'll just leave it as default and hit OK. So now what we'll get is we should get a nice spiral, like a ramp down. So we get one continuous toolpath there. I don't really use that one too much. Pencil, what's pencil? So if you're doing a mold, click and hold to get the select menu. Ah, thanks, Brad. Yeah, good point. Let me see if that would work. On this guy here, edit, under geometry. Let me delete that. If I click and hold, I'm clicking and holding. I'm not getting that. I'm having issues with my computer. You guys, I don't know if you're seeing this on your end. I'm just going to cancel that operation to leave it how it was. Okay. All right. Next, pencil. So if you're doing a part like this, and let's say if we did a scallop toolpath, and our geometry is here, and my selections are not cooperating with me. Sorry, guys. This kind of stuff happens when we do these. There we go. Trying to grab that edge. Everything was working until, you know, we're live, right? Okay, you know what I can do? We have some, from the sample, we have that. Okay. Does it get to the middle? Yeah, so when you do this kind of stuff, what pencil does is it will drive the tool around like the tiny areas, like here. So after you do all your machining, it will then come through and give it a nice, let's see one thing, selection filters. Yep, they're all selection priority. Yeah, they're all. Brad suggested I look up here. I'll come back to that, guys. Okay, in the effort to save some time, I cannot believe we've only got 15 minutes. All right. So what pencil will do is when you're roughing this, you'll come through and then select pencil, and it'll give it one nice contour. And if you're doing mold making and things like that, you can really notice it. Because if you're doing like a scallop here, and let's say your tool is going left to right here, you get a lot of, in my opinion, it's kind of ugly toolpath when it hits these areas, if it's going left to right. Or even on this guy, sometimes, if you're going this way. And then what pencil will do is it'll clean it up nicely. Okay, so pencil, and I apologize for my selections not working. Horizontal, what's horizontal? It'll do exactly that, whatever the name is. So, what's the boundary? I'm just gonna do a silhouette, and let's just hit OK. Oh, let me change my tool. Let me come grab a different tool. Should have grabbed a flat tool. Let's come into here. And let's do a 3/8 bullnose and hit select. And now I'll hit OK. So what horizontal will do is it'll grab and find all the horizontal faces. I don't use it too often. I kind of prefer Pocket, 2D Pocket, a little bit better. But horizontal is a 3D strategy. So if you want to be... I don't like to use the word lazy, but if you want to make a part with less mouse clicks, you could do the whole part with like a horizontal, perhaps, to hit all the flat faces. You can do a 3D contour to hit the vertical walls or steeper walls. And then you can come in with perhaps a parallel or a scallop. And a combination of these tools with minimal mouse clicks, you can hit the whole part. So that's calculating. I'm at 63%. Let's move on to the next one, spiral. This one is really cool. I like this one. And then we've also got radial. It's the opposite of spiral. So let's look at what that one does. And hopefully I'll be able to get it to work with my selections here. And I'm going to come into this setup and grab a ball end mill. Let's use, let's grab this 1/8 ball. Give that a moment to load. I'll take a quick look at the chat. All right, looks good. Brad is handling all that. Thank you, Brad, for being my wingman. And my connection is slow today. All right. Geometry, I gotta pick a center point. I'll grab that arc or circle. So the center point there. And then the machining boundary, I can do a selection. And let me grab this. And then I can give it an additional offset. I'll do contact point boundary. Passes. You can give it some choices here, different choices. Spiral, spiral with circles, concentric circles. Pretty cool. I'll just leave it at the default. You can change it to counterclockwise to clockwise or counterclockwise. You can give it an inner limit or an outer limit. Super powerful toolpath. And control the step over. So I will just let that guy run. All right. Let me show you something that I did on this part here. Came out really nice. I had to do a logo like I was just talking about. Where did I put that? Let me bring this here into the view. So I was tasked on that part to make this logo. So I actually did it in Fusion, and you can see the result right there. Turned out pretty good. I did it at my buddy Chris's shop, Datron, and it came out really nice. And I manipulated some of the tools in Fusion to give us some depth. So I feel it came out really nice. And again, you can utilize and leverage some of the tools in Fusion to get the toolpath you want. So there's that part there. And then I'll turn that one on. And let's turn this one on. And turn this one on. And then I did a trace to give me the tracing those lines there. And what I did is I leveraged the center point. So if I look at like on the passes and the geometry, the center point, see how it's highlighted, was right there. So by moving that center point, I was able to achieve the result that I wanted. And I played with it a little bit and until I got what I wanted, but it came out really nice. And if I look at this one, which is, if I turn the visibility off, it's this one here. So this one had a different center point. And if I come into here, if I look at the point, so that one was there. So if I shifted it more this way, those lines would collapse differently here. So I brought it a little closer so they collapse so that I get the nice effect there. So I feel it turned out pretty darn good. And again, leveraging the tools you have in Fusion, you're able to achieve some really nice things. And I'll turn those on again so you could see it, what it looks like. And again, I was playing with the center points to change that where it collapsed there. Coming up on the top of the hour, guys. I am so sorry. Let me take a look. All right, Brad, I see your comment. Thank you. All right. What's next here? So we talked about spiral. So radial is slightly, it's the opposite. Let's see. Where is this part? Okay. So if we wanted to come into here, we just did spiral, where it'll spiral, and then radial. So what that will do, it's the center point. Let's pick the center of this guy. And is it going to give me the center? And of course, let me move my mouse off the screen. I apologize, guys. It's kind of like when you teach your dog to do a trick, and then your friends are your dog does it and executes rollover every time, or does some trick, and then your buddies come over and you say, "Hey, watch my dog do this trick," and then the dog doesn't do it. When you want it to work, it doesn't work. Don't know why. There we go. So we got the center point there. Selection. Let me see if it'll let me grab this here. And same thing. It's not I. You know what I can do? Let me just cancel that, and we should have that already here. So we got the spiral, we've got a radial. So what the radial does, it just starts at the center point and then comes outward. Again, to give you a little bit of a different toolpath. Let's quickly move to morphed spiral, just because that's in order here. Actually, that's, yeah, also in order here. And what morph spiral does, you need to give it the chains, and it'll take this outer edge and this one, and it'll morph it as it transitions from the inner to the outer, or outer to the inner, based on your selections. All these toolpaths operate as far as the, your selections. You'll use geometry to do your selections, and then passes you can do some manipulation. So pretty easy to select toolpaths here. And then here's a little different with some slightly different selections here under geometry, where all these ovals here in the middle are selected, so you can see the different. I'll just cancel that so it doesn't have to recalculate. So you get a little different output. Here's that pencil we talked about. Horizontal, we had talked about. It hits all the horizontal faces that the tool can hit. And then project. What's project? So if you've got some geometry and you want to put something on there like text, so I could take that Autodesk logo and project it here. But on this particular one, there's a sketch. If I come into here, there's this sketch that is just that shape there. And you simply will project that down onto that surface. And again, because I'm having issues with my selection today, I'll just go ahead and use this one. We'll right mouse click edit, and we'll take a look at the curve selection. All you need to do is select the curve, machining boundary. It's using the silhouette, and it's literally going to just project that guy down. Passes, I'm not going to even worry about that. Linking, I'll leave that all as default. Hit OK, and I will turn off that sketch visibility. So you can see how that toolpath will just project down. So that's how, if you wanted to engrave some text. You need to be mindful though, if that curve is really great, you won't get an even, and then you won't get an even toolpath strategy. Just the output won't look that great. Where we at on time, coming up on top of the hour, blend, morph, and flow. Let's see here. Do we have anything that I can quickly show? Let me look at the chat. Anything in there, Brad? Looks like everybody's good. Thanks everybody for the likes. We got 70 folks watching, 38 thumbs up. Thank you. We appreciate that. Any last minute questions I can answer? Drop them in the chat. Brad will let me know. All right, looks good. Let's come into here and let's see if we can. So I did already a flow and I did a blend. They're very similar with how they look. There are some subtle differences between the two. Let's come into here. I'm afraid if I try these that my selection tools might hang up. So yeah, there we go. I'm getting the same thing. So you'll select the surface and yeah, it's not working there, but I apologize for that, guys. But here I selected the surface, then I selected this outer edge here and then that outer edge, and it will give a nice toolpath. There are some settings here under passes. You give it the step over, right? You can also do multi-axis if you're on a multi-axis machine. A lot of goodness we have here. Flow, very similar selections, except on the flow it's using the UV curves of the surface, so you can go along V or along U, and then the number of step overs, so you tell it how many steps to machine across. So that's based off the surface vectors. All right, let me come back to this. Are there any questions, guys? Drop them in the chat. Let's see. No, we're all good. Ayala, Mr. Coffee Paul. All right. Boy, that hour went quick. It is a privilege for me to be here and share some of the things that we can do with Fusion 360 and how you can utilize some of these toolpaths on your parts. I do recommend going to the CAM samples, taking a look at those, and then what you can do is right mouse click and then copy and then just reselect the geometry. Super powerful and easy to create toolpaths. And I don't see anything from Brad in there. And we're coming up on top of the hour. I would go longer and cover some of those toolpaths today. I can't do that. Apologize. The next live stream, Brad will be doing next week. I encourage you to check those out, same time. And I'll be the week after that, and I'll go over steep and shallow in great detail. And even then we'll come into some multi-axis stuff. So any questions, drop them in the comments, and we'll do our best to answer those. With that, you guys all be safe, have a good day, and we'll see you next time. See ya.